Ho ho, ladies and gentlemen, days and dems, children of all ages, welcome to another day at my job. We have another build for you today. A DL380 Gen 10 build. It's a master failover with MSA. There goes my hardware, all my cases, my chassis. It's going in. You got 128 gig RAM builds with an Intel Xeon X540T2 processor. Yeah, you guys get to see the whole process. Start. And that's not light, folks. First episode I told you I was used to doing server builds. Now you see that's knockout. This is what your DL380 Gen 10 looks like. This is a CTO build, so ours comes with proc, RAM, RAID already installed. We have 4 fans, the CD-ROM and the front IO ports already installed. Usually this is all blank, these aren't here, you'd have to install these things, but we get a custom order for our clients. Alright, we have our server unboxed, got the tour of it. I'm going to remove our PCI riser. We're going to install our NIC, add an additional NIC to the onboard. Installed. Right. We also have a smart array controller. This is so we can use our SAS controller for our MSA. Now our SAS controller, we have a feedback cable. What you want to do? So this is your SAS connector, SAS card. Take your feedback cable, get it in there. That plugs into your corresponding jumper, J1, 2, and 3, on your PCI riser. Alright, so that's how that's going to look. You have your SAS card, your feedback cable plugged into the actual riser itself. I'm going to reseat that. Anything else that's in there? This build calls for 128 gigs split evenly between two procs. As you can see here, we have a bay for 2 processor slots. We have not received this yet. We're still waiting on FedEx or whomever to deliver, so parts are on order. But we do have our initial procs. We're going to set up and start this whole process going with 1 processor, and then later on, once we get everything else, you'll see me add the second. I've been doing this for a while, but you should always RTFM, read your manual, and verify the correct RAM configuration for the amount of DIMMs that you intend on using. I am using 8 DIMMs total, 4 DIMMs per proc. So mine are all in the white ports. And last but not least, at least on this build, we have our serial port connector. Now, this is your simple DD9 serial port, but the server doesn't have it built in. It's an add-on part. Push out that plate in the back, get it connected in the port. All right, thank you. So for this build, these are all of our internal parts. Your serial cable, your SAS and NIC, the extra RAM. Just keep in mind later on we're going to populate this proc port and the RAM that goes in here. A total of 128 gigs. Alright guys, so last but not least, that's done. These are done. Alright, so everything's installed. Air baffle's in. Air baffle helps throttle the air where it's supposed to be. So if there's no processor here, your air baffles, you kind of guide your air towards, where it's needed and required. So make sure it's in. And last but not least, power supply. Here's our new 800 watt power supply. What you do, you have these two ports here, as you can see. Pull out blank. Good to go. Alright, so now that this server is complete build right now, so we got our other hardware. We don't need the gym. Everything's gym. Everything's gym. Good job. So, if you don't know your RAM configuration and everything else, this on the inside of the top flap will tell you everything you need to know about a server, about how to configure a server. Alright, so same treatment as the one prior. We'll start with your serial cable. Take off your mounts. Pop out the blank, that's gone. Get it in place. And then you take your mounting hardware again. Get it in there. Next up, in no particular order, is the RAM. Pop it out. These are 16 gig sticks, HP RAM. I'm sure in some way, shape, or form these are special for a server, but not really. DDR4 is DDR4. No DDR4 is it has this nice little wave in it. I don't know if that translates on camera or not, but DDR4 has a nice wave. Alright, some more trash. So here's where we take out our PCI riser. Just this thing. Kind of rock it out. So it's up. Alright. Just like the first one, we had our NIC top. We're going to put our SAS on the bottom. packaging on top of package. Alright. Connect our feedback cable first. Connected. Connected. Feed that how you like. Alright, now that those is done, drop our riser back in. Make sure you line it up with all its mounting posts. You see these two pegs here, they line up with the case. Slide down, make sure you're in your port. Make sure you hear a firm click. Once you're done, you take your thumb screw, push down and twist, pull that down, just like the previous. We're good to go. Seeing as this is a master failover system, both servers will get identical setups. Check for additional hardware. Alright. Two down. Let's not forget. Power supply. Again, you pop out your blank plate. Add your redundant power supply. So now each server has two power supplies, serial port, and this Suse and NIC that we installed. You may notice NIC ports here. These are on board, as are these, are just in different locations. To be perfectly honest, these are built into the board. These are additional 4-port NIC that's added after build. Why that is, couldn't tell you. That's just how CTOs come from. All right. Last. HD3710 MSA enclosure. All right. This is our HP D3710 MSA enclosure. Comes with mounting equipment, manuals that tell you absolutely nothing, but go to the website and find the manual. This is where our hard drives are going to go. So if you remember in the beginning, our server has 8 hard drive bays, but we're not going to use those hard drive bays. Those are completely useless to us on this build. This is where our hard drives are going to go, and both servers are going to share these drives. So think of this as an external a giant external hard drive, pretty much. That's communicating via the SAS connectors. The one would be a main server, your master. One would be your secondary server or your failover. Both using the same thing. So if the hardware fails, the OS, your logical volumes, are stored on a separate location with its own redundancy and its own set of rules, and it just communicates with your hardware where your everything is running from. So it gives you a lot more flexibility, and it gives you, more importantly, redundancy on how to set up your infrastructure, your network. I'm gonna cut that out. Alright, so this is where our hard drives are gonna go. I believe for this order we have 16 hard drives. Start it up. Gigs. This is going to start our set. We have two 600 gig drives that we set up. Another 600 gig drive. These are SAS drives. Two 600s so far. This is a 1.8 terabyte SAS drive. We're just gonna pull these babies up, put them out the way. What we want to do, take these blanks, fill in those holes as we saw earlier. In front of our server look pretty. Alright, how this works is, this is redundancy, people. So from controller A, 1, server 1, port A. Controller B, okay. Controller B. Server B. So that's our redundancy right now. 2 different servers. For the build, we're gonna go that way. So to set up this master failover, I'm going to start off with this, do my updates, set up everything as I can. Once I do my updates on the server and the hardware itself, it'll update both controllers. That's why it's set up the way it is now. And once I start, I'm setting up my secondary server for the Linux and the other things. I'll do this on the same connections here, and that'll be that. Thank you for joining me for my build of my MSA, master, and failover server. There's more to come, another proc, more RAM, but that's all, folks. Like, share, subscribe, please. You have a good one.